What up, everybody? Sorry for the 2-minute delay. It seems that my computer does not want to function as it should, which is normal for my computer. So the moment that it tried to do anything, totally locked up. So, which is a good example of why we didn't do it last night, computer issues. So at any rate, I was too tired to deal with them, so I said, forget it. But we're here tonight, and hopefully it's streaming, and everybody's is here. Let's see here. We'll send something out. No, doesn't look like any of my features working, so I don't even know. Somebody wants to make a chat. We'll see if it's working. Check. There you go, 12. Yeah, I don't know what's working on, what stuff is messing with my stuff, but anyway. Okay. So we'll do a little exam prep tonight, look at some questions, and hopefully you got your code books for those that are, some of you probably have already tested by now, some of the regulars that come in here. So again, would love to hear some results from you, see how you're doing, and kind of get some feedback. Hopefully the audio is not too loud, sound okay. Again, it's been a minute since we've done something. I've been a lot of stuff. I'm actually back in the office now full time. So again, back at, as most people know, Encore. So I'm back in the office. So by the time I get done and everything, it's a little bit different to get set up to do these live streams. I have to come back and then make sure I get everything. Usually wasn't that far of a commute from my office in the other room to here in order to get ready, but now it is actually a commute. So anyway, we're here. So also, again, I get a lot of requests from people who want me to give them a quick look at the fast tracks. Again, just a quick overview of that. So we're going to try to do that as well. But again, we're going to look at some code questions today, and hopefully everything will go okay. And I still got to load that up, okay? And yeah, Polywally Code Man, yeah, all over the place. So hopefully this COVID thing will be over soon. I am so over that as well. Wearing the masks in the office, all that kind of stuff is, I have a funny feeling that on November 4th, we won't hear as much about COVID, but that's just a prediction that I'm making. Okay. Don't like to play Nostradamus, but I will. Okay. So again, we'll give a quick look, and while y'all are waiting, I am going to try to get this thing loaded on here for everybody. Again, I had a little bit of an issue getting on. I'm not sure what was going on. As you all know, I have a fairly powerful computer now. That shouldn't have been an issue. I don't know what was going on with it. But it was. Of course, it also has to do with software. A lot of software updating, things like that obviously caused a problem. So I had to get all that squared away. But we're all squared away. Right now, let me just make sure that I'm where I want to be. I'll do a quick overview real quick for those that aren't familiar with it. For those that aren't familiar with the program, I'll give a quick overview of what the Fast Track is. For those that are familiar with it, and bear with me. Also, feel free to ask any questions. And I'll go through this pretty quickly because I know there are people that do want to know a little bit more about the program, so I want to make sure that I cover that for them. All right, so most of you know the Fast Tracks program that we have here is not the Holy Grail. It's not designed to teach you everything about the National Electrical Code, but it does teach you what you need to know about the National Electrical Code to be successful in an exam and preparation. But it also gives you a little deeper insight, and I think one of the biggest things is that every code competency review I grade personally, and with hundreds of students in the active program right now, the active quarter. Again, some of the others back when Tim was in there, and and Jay was in there. That quarter is cycled out. And so I've got very active new students. And again, we have hundreds of students. And again, with submittals of competency reviews and things like that, it takes a lot of time. And also, you might be aware that we have a residential, commercial, industrial, grounding and bonding programs. So again, those have the same concept. I have to physically grade those as well and give feedback to the students. And some of you that might be out there are actually in multiple programs. Some of you are actually in our residential or our commercial as well. So you're probably familiar with that as well on both ends of it. By far our most popular course is obviously the fast tracks. That is the most popular of what we offer. And everybody knows that I'm here to answer questions as best I can anytime that you need it. I try to make myself available. God, that hat looks so dorky. Still waiting for Jay to send me a hat. You know what? He ain't sent me a hat yet. All right, so he did send me some face masks, and I think we've got 2 left. So if anybody wants one, email me, and I will send you out a face mask, one of his face masks with his logo on it. We'd be more than happy to get that out to you. All right, so let's kind of look at the fast tracks real quick, just to give it a look, and I'll run through it, and we'll go right into some questions after we give it just a quick look for those out there who wonder what that program looks like. So in the fast tracks program, you'll get a console. You'll log into your console. You have access to it for an entire year, 12 months. People have asked me about our 90-day, our 60-day, and our 30-day programs, study plans, I should say. That's probably why it's a problem, is because I said that. Those are just study plans that you would use. Anybody doing the fast tracks could use any of those plans if they wanted to. That's just people need a way to study, and that's a way to study. And so that's why we put together those study plans. And they're free to download the study plan. That's over on our masterthenec.com, right on the main page. Free to download that at any time. If you want the 30-day one, you really want to test yourself, just all you got to do is go over to the 30-day plan page and go to that where we have the 30-day fast tracks, and you'll see where there's a download for that. Okay. All right. So anyway, this is a program, give you kind of an idea what it looks like. This is a program. Each one of these are specific units. You need to do all the information in the unit. There's study information, there's flashcards and all in here. But really, you got to do the reading material. You got to do the reviews. And then, of course, you have an assessment. Now, this is the 2020 Fast Tracks version. Okay, now, and there's videos in here as well that you can watch. And then, of course, there's, again, the drill that you have to do. All right, so a little different than the 2017 edition, but you go through every unit before you go to the next section. Okay, so again, when you get down to the 5th, you'll get to that one, and you'll go through that review, and everything will be done. Okay, so the same thing would be at this one here, section 2. You just go down through each one of these, all the way down, and then you'll get your Unit 9 assessment, everything as well. Okay. All right. So that's pretty much how you move through it. And you move through every single, you got to read all the reading material as you move through it. Okay. All right. Now here's that video about how to watch the root. That's an old video. I did that quite a while back, but again, it really teaches you how to look at a question and dissect the root. We'll do some of that tonight as well. And I should remind folks, I would be remiss if I did not remind you that I am doing a seminar, 6-hour seminar on essential calculations. And that is going to be on, I believe, the 21st of November. And it's $99. But again, you get 6 full hours, and we will cover everything from 1 family, 2 family, multifamily, transformer basics, motor basics. We'll talk about every calculation that we can think of that it's going to that are going to be essential, and that'll be covered. Some of the questions will come from this program, the Fast Tracks program, especially the ones that students tend to get wrong a lot, or they struggle with. We're going to be bringing those, and we're going to be answering those as well during that seminar. So if you're interested in that, go check it out on masterthenec.com. Also, you can go to electricalinstructor.com as well if you're interested in that. Okay. All right. So let's get past that, and let's kind of look at some practice questions. Let's go down. Let's do some master stuff here. I'm sure it's going to give you my little notice up here, as it always does. Yep, see, my little notice. Who cares? All right, let me make sure this is showing up right on the screen. It is. For you, and hopefully you got your code books. Now, I am using 2020 NEC. So, again, if you want to answer it with the 2017, that's perfectly fine. But this is based on this one here is based on the 2020 NEC. Now, a couple things. People have asked, hey, what's up, GD? Some people have asked, are there any errors in any of these questions in the mega folder in your Fast Tracks program? The answer is yes. There are a couple in there that I have identified that are a bit problematic, and they're not really good questions, and they have already been submitted to the actual author that supplies these questions. I do not write these questions. But as you've heard me say before, a good question or a bad question is still a solid question in order to be able to, because if you can identify that it's a poorly written question, and you can identify that, and you send me the email, you say, Paul, I don't like that question, or it's wrong, then you did good, because you're able to identify the fact that there was something wrong with that question. So if you're going online and you're actually encountering what you feel are really poor questions, that's okay, as long as you're able to use them to maneuver through the code, because that's the key, maneuvering through the NEC. Now, hopefully you out there, if any of you, Saran, is that good night and you're leaving already? Did I bore you that quickly? Or maybe you're not leaving. Okay, sorry, but good night to you as well. And most of you also know that I do this on Wednesday nights, but again, obviously Thursday night. So again, you never know when I'm going to pop up and do one of these things. So there's no rhyme or reason. Just when I feel like, come in and offer some training. So I'm not sure where I was at, because again, I'm accused of going all over the place. So again, I apologize. But at the end of the day, any question can be utilized as a good question. Even if it's wrong, if it makes you think and it makes you flip through the NEC, then it's not that bad of a question. Okay. All right. So they got a kind of a question on the screen. Hopefully everybody can see it. I can't really blow it up any bigger than that without really losing the flow of it. So the question states, in a commercial repair garage work area, which of the following single phase receptacles, if any, are required to have GFCI protection? 15 amp, 125 volt general purpose receptacles for hand tools and portable lights? Or 2, 20 amp, 125 volt receptacles serving electrical diagnostic equipment only? So is it A, B, C, or D? Is it only for the 20 amp, 125 for diagnostic? Is it both 1 and 2? Is it 1 only? Or is it neither 1 nor 2? So it's kind of one of those things. Look it up in your code book, 2020 edition. Although, again, you can find this answer in your 2017 edition. Caleb doesn't give me a code reference, but he says both 1 and 2, rather than say the answer is B, Paul. So he says both 1 and 2. What's your code reference, Caleb? I know Caleb's gonna say he doesn't have his code book with him tonight. One of the only people I know comes to a code class with no code book, purely going off memory. I should mention, our are some people must be liking these because my tabs, the P tabs, can't really see them with the instructions, have been really going out the door. I'm not sure. Obviously I'm not reinventing the wheel here, but people seem to like the white on black, or I guess black on white. I know that the tabs on my code books, this code book here, stink because they're the transparent colored ones and you just can't see the daggone things. But people are liking these P tabs, so glad people are liking them. All right, so anybody got a code reference? If you got your code book and you look this one up, hopefully you know if you're preparing for an exam and it's exam prep, that you want to be able to look this up in your code book. Now, this is a commercial repair garage, okay? And we're talking about what? Receptacles. And again, it's a GFCI protection requirement, okay? So one of the things here, you might say to yourself, there's two ways you could go here, right? Well, one of you probably say, well, I'm going to go to 210.8. Okay. Well, I've got your code. I got my code book, and I'm not putting it on the screen. Mandingo's going to kill it. I'm going to put it on the screen, but I'm going to look in 210.8b and see what it might say. Well, it says a bunch of general information, but the question was a commercial repair garage. Okay. All right. So if you've got a tab for that, and like I said, these tabs you cannot see at all. These are awful tabs. If you say to me that somebody says to me they didn't like my tabs, I would tell you, compared to the things that the Easy Tab are coming out with now, I would think you'd love it because these suck. They really are poor tabs. I mean, they really are. I mean, you can't even see them. I can't imagine a student sitting in an exam having to deal with that. Just can't imagine that. All right. So, everybody, let's see, who gave an answer? Who gave a reference? And we'll look up the reference. Let's see here. We've got, Caleb's got the B reference, and then Mandingo gives 511.12. Okay. So I'm in 511.12. Okay. So help me out, Mandingo. Where are we at here? No, it was not it was Mandingo that said that. So let's see here. Where are we at? And then we've got a 511.2, which doesn't exist. Okay, so that's not going to work. So help me out here. Again, the job is for you guys to be able to maneuver through this and find out your reference. Okay, so I see two references on the screen right now. All right. And while you're doing that, I should probably go on, and while y'all are doing that, I'll make sure I get my code book up here in the background. Hold on with me so we can go look it up together. I wasn't going to do it, but we'll do it. Hold on. While y'all are looking this up, let me see if I can't get this loaded on my computer. Somewhere in here. Bear with me. While y'all are looking, I told you I had computer issues. Again, somebody were to say, Paul, your web stream is unprofessional, then my advice would be, there's another gentleman out there who does code and does exam. My advice would be, go listen to that gentleman. Okay. Not sure why it's not loading. Interesting. Can't get it to load. Huh. Interesting. All right. So anyway, this references receptacles, and let's go here. And you have those that have the 2017 code. So some of you did say 511.12, which ultimately sends you to 210.8. And of course, y'all see that it's 210.8B8. And as far as references, some of you had the 511.12, but you didn't make it back to the 210.8B8. Okay. Right, that's just a warm-up. That's just a warm-up. I kind of gave it a... Oh, wait a minute. I might have to move y'all's thing here. Hold on. There. Otherwise, we won't be able to see all the question. There we go. Okay. So, and I'm not sure this is going to work because everything is not working right. Let's go over to the NEC so we can see where that was. So there's, yeah, it did work. Okay. 511.12, ground fault protection for personnel. Ground fault protection for personnel shall be provided as required in 210.8B. And of course, here, remember this rule right here is all 125 volt through 250 volt receptacles supplied by single phase branch circuits. Remember that? And then 8 is talking about that garage, accessory buildings, service bays, and similar areas other than vehicle exhibition halls and showrooms. Okay. So that's what requires. So it's both in the answer. Okay. All right. Let's go back to the main. Let's browser. Okay. Steve. Awesome. Steve, congratulations. Don't I have a button for that? Hold on. Let's see. I'm totally discombobulated here. Excellent, Steve. Congratulations. Now get out there and make that money. All right, let's go to another question. And make sure it's not cutting it off. Okay, there you go. Okay. Next question. A given. We have 4 size 2-aught AWG conductors contained in a 2-inch trade size conduit. Enter a pull box on the east side. Okay, got a picture of box now. East, west, north, south. Okay, on the east side. Okay. The conductors then make a U-turn in the box and go out a 2.5-inch trade size conduit on the same side. Ooh, so we have a box. And it comes in from the east side, and the conductors come in, they turn, they go right back out. Don't ask me why it comes in with a 2 and then goes out a 2.5. It just does. On the same side. What is the minimum distance from east side of the box to the opposite west side in inches? Now, think about this question for a second. Now, give me a code reference where we'd find this answer, guys. But think about this. You know, you were thinking that it's going to say, what is the distance between the raceways that are on the same side? Right? That's what you were thinking. Right? You know you all were thinking it. But that's not what it asks. So it wants to know the minimum distance from the east side of the box to the opposite side. Okay. What do you think? Throw me some answers. So you got 12 inches? Then you just give an answer. But it'd be nice if you give me the reference to the code first where you need to be. 12 inches, 17 inches, 20 inches, or 15 inches. To be honest with you, inside of the Fast Tracks program, this one also, and you know what? We don't know the answer right here might be right or wrong. You know, this is one of those ones where it's going to make us think about it. But it is going to be, this is a U-pull. Okay, so it's a U-pull. All right. So kind of keep that in mind. So where we need to be, first of all, give me a section. Somebody give me a section where you think you need to be. What says times 6. It's not the section. Y'all are rusty tonight. We're all rusty tonight. We're not giving codes tonight. 314.5? Really? Elwood? I know, Elwood doesn't have his code book. I'm pretty sure. Hold on. Elwood, I want to go look at 314.5 because last I checked, there wasn't a .5, but let me go check. And say 314 doesn't help me. Y'all aren't helping me here. There's a code section that specifically deals with, okay. Now we're cooking with grease. But 314.28 is pretty broad, okay? That covers both straight pulls and angle pulls, covers everything, okay? Okay. Okay, A2, getting better. Still have no answer yet, but we're getting better. Incidentally, I should say that in my seminar that we'll have on November 21st, obviously I will be covering box calculations as well. Okay, we'll be covering all of the box calculations. All right, so the only significant thing that we need to remember right here in this one is that we have a trade size 2-inch and we have a trade size 2.5 or 2.5 inch. Okay, the conductors are irrelevant right now. All right, so let's go to the code really quickly. All right, we got somebody gave an answer, 15 inches. Okay, 15 inches. All right, somebody stepped up to the plate. All right, let's go to the NEC. Thank you, Brian. All right, now let's see here. Let's get rid of that. All right, let me go back to the top. All right, so let's go into code. So we do have, y'all did give the reference eventually to the place where we need to be. And let's scroll down to where we want to be. Okay, so again, so you're at 314.28, okay? Now, I should say of the question, it was, it's significant to the fact that it at least gave me sizes. So again, this only applies to 4 and larger, right? So that was significant. It did tell us, so we know that. Now, are we dealing with a straight pull? No, we're dealing with an angle or a U-pull. And it says where splices or where angle or U-pulls are made, the distance each raceway entry inside the box or conduit body and the opposite wall of the box or conduit body shall not be less than 6 times the metric designator of the largest raceway in a row. Okay. It says the distance shall be increased for additional entries by the amount of the sum of the diameters of the other raceways entries on the same row on the same side, same wall of the box. I'm going to assume here that they're on the same row of this box, okay? All right, so we know it's 6 times what? Largest raceway. 6 times 2.5. Got your calculators, right? I know you do. 6 times 2.5. Okay, that's 15. Now, we're going to assume that the author of this code, of this question, put them on the same side. So it's saying the distance shall be increased additional entries by the amount of the sum of the diameters of all other raceways in the same row on the same wall. Okay. So it'd be 15 plus 2 be 17. Hold on, let me get my thing back here. Okay. So I see 15. Monty gives 15. Steve didn't give but he did. Okay, just didn't add it out. But yep, went for that method. Okay, with you, Steve. So let's kind of go back to the code question. All right, and we have obviously 15, 7, 20. So in an exam, some plausible answers that you could throw out of the way to, at least if you didn't know the answer, you're at least increasing your odds. Obviously, 12 inches is not going to be an option here. because you use the largest raceway, it's 12.5. So 6 times 2 would be 12, but it's 2.5. So obviously 12 can go. All right, so now the question is between 3. So you just increase your odds on an exam. So one of the things I recommend for people on exams is always look for the obvious one that couldn't be and get rid of it, because it at least increases your odds. So if I guessed at this, I'd have a 25% chance of getting it right. If I eliminate one, I just increase those odds to 33% approximately at getting my answer right, right? Okay. So there you see 2.5 times 6 is 15 plus the 2. All right. So hopefully that, now, like I said, incidentally, for those that didn't get that right, again, you look for a lot of those type of calculations to sprinkle in, when you're doing an exam. Every state's different, but you really need to know how to do this pull box sizing. Remember, if it's an angle pull or U-pull, it's not going out the other side, then you don't have the straight pull. If I have raceways coming in one side and go out the other, and even though I have conductors that might be doing a U or angles, remember, you have to do all possibilities. Okay, I took a lot of crap from people who said if you get an exam question that doesn't show you the route of the conductors, that you can't answer the question. And I tell you, that is bull crap. If an educator ever tells you that, run for the hills. It's BS. I know this for a fact because we've written questions that don't show the wires, but show a statement that they're going to be larger than 4 gauge or 4 or larger, and then it shows you the raceways in a box, right? And so you have to think about all the possibilities when you're sizing that box, and you size it for the worst case scenario, okay? So Elwood, when it comes to the back, you have an allowance for that if you're talking about the depth of the box. So when you have the depth of the box and it's coming through the back, if you go back to the code, and it should still be, the 6 comes from, the 6 times came from 314.28 A2, Ronald. It says 6 times. That's what an angle pull. Remember, 6 angle, straight is 8, angles is 6. Kind of a cut. As you see right here on the screen, it's probably better. I could just show you on the screen. Right here, 6 times, right there, because it is a U-pull. It made that statement in the question. Okay, so that's where the 6 times comes from. In this case, there was no entry on the other side, so there was no plausible straight pull to begin with. So you wouldn't go to the 8 times. So this is where you would do it. And then it just tells you to take the largest raceway, which is the 2.5. Okay. And then again, when it says the distance shall be increased for additional entries by the amount of the sum of the diameter, which in our case was 2 inch, of all other raceway entries in the same row on the same wall of the box. Remember? So it's on the same east side. Okay. All right. Now, the exception, again, so I'm talking, I think it's Caleb, where the raceway conduit is in the wall of the box or conduit body opposite a removable cover. So that's what it would be on the back, because you got to have a cover to any box, right? The distance from the wall to the cover shall be permitted to comply with the distance requirements as a 1 wire per terminal using table 312.6a. So this is why typically the boxes aren't as deep as they are for the long, because you do have the allowances under this table. And if I click that table, you can kind of see here what we're dealing with. So and again, it says to use it as 1 terminal. So if those were what? Those were 2/0, I think, in the question. Hold on, let me look. Yes, they were 2/0 in the question. So 2/0 in the question are going to leave us here. And it means it has to be at least 3.5 inches deep. Now, you got to remember something. This right here, you still got to have the depth of the box that can handle the actual fitting, right? So you're going to still going to be making sure that your fitting is, so your depth is still got to be, if if it's a 2.5 with a lock nut on it, it's still going to be deeper. 3.5 is still going to be deeper than that. Okay. And the only reason you can have a reduction there is because you have a removable cover, so you can pull the conductors out and refish them back or re-pull them back. Now, one thing that is a kicker here for most people is that, I'm just elaborating here for Elwood. If you're coming in the east side and then you're turning and going out the back, so your box may only need to be 3.5 inches deep, but you got to remember, since those conductors are coming out and leaving another entry in the exit in the back, you have to have that distance between the raceways, right? So that also ends up being 6 times the largest raceway between them. So that means that back one's going to be pushed off further out into the box, right? So you'll have enough room to come in and then turn in. So you still have that separation between the raceways, right? It's still required. And to show you that, so you see that is right here. See here? The distance between raceway entries and closing the same conductors shall not be less than 6 times the metric designator or trade side of the largest. So in your case, Elwood, if it was 2.5 coming in the side, east side, but then it went out the back with a 2-inch, then you still, from the 2 inches, it would still be the, we'll say 2.5 coming into the east side. It would be 2.5 times 6 from the east to the west dimension. But then the one that's going out the back, that would be 2.5 times 6. And that raceway going out the back has to be moved over enough so that the entry for the raceway coming in from the east and the one going out the back has to at least be 2.5 times 6 in order to have that separation. So that's 2.5 times 6. So they'd have to be 15 inches apart. That pushes them away. Okay. Hopefully that explains it. I'm going to have some graphics of that, obviously, in my seminar on November 21st, because I'm going to try to cover, whoever attends that, I'm going to try to blow your brain up with every possible calculation that I can. All right. Let me go back. Of course, you might not need that if, depending on how proficient you are with calculations, it's not for everybody. I'm going to have the seminar whether I have one person or 50 million. So I don't know. Brittany knows how many signed up. I don't know at this time. All right. Next question. Good stuff tonight so far. Not bad. All right. So continuous duty motor rated more than 1 horsepower with a marked service factor not less than 1.15 shall have a running overload protection sized at no more than blank of the nameplate rating of the motor, where modifications of this value is not necessary or permitted. Okay, so yeah, it's a Saturday. It's a little more than an evening, Ronald, because it's 6 hours. So I'd have to go look. I think it's 10 o'clock till 4 o'clock or something like that, with a 1 hour break for lunch. People can go do their lunch. Moise, I'm not sure. Hi, Paul, did not UW. Not sure. Oh, didn't know I streamed. Yeah, I was supposed to stream last night. I had computer issues. Yes, my big computer issues. And then I would be honest with you, I just started going back to the office and I was beat. I was just too tired. And by the time I tried to sort it all out, I was just too tired. So I decided I'd make it up to everybody and come on tonight. Sorry. Hopefully if you subscribe to the channel, you get notifications when I stream, hopefully. It used to be I never would tell you when. I just do it at any given time, right? I like to at least to give you a little bit of notice now. Okay. All right. So Alan, Steve is giving us some help up there. Don't y'all cheat and look up there at the comments. So we're dealing with what? One, we know it's a continuous duty motor. We know that it's rated more than 1 horsepower. We already know the service rating, service factor, which is 1.15. So it's not less than 1.15. So we'll assume it's 1.15. Shall have a running overload protection size at no more than blank. And notice it says where a modification of this value is not necessary or permitted. Okay, for some other weird reason that's not permitted. Okay. So where would we find this in the code book? Well, obviously, if I was dissecting this, I'm looking at dealing with what? Motors. And the question is asking me about what? Overload protection. All right. So if you've got your tabs, or if you have your nifty P tabs of ours, they're much better than these tabs right here. I can promise you that. And you, but a tab's a tab. So whatever. But I can't see these tabs. So it makes it really difficult. Oh, what's different with our P tabs is that I actually include the A, B, C, D, E, F, G, so you can actually index your index. How's that sound? Index your index. Okay. Well, there's 100 and some tabs in that bad mamma jamma. Okay. And they're smaller. So they're not as big as those other tabs. Okay. I do see some references in there. Thank you. Thank you. All right. So if I was looking at in the code book, just again, I could pull it up on the screen, but I think most of us are already there. But if I was looking in the back, you think, well, what would I look under? Would I look under overload? Well, you can look under overload if you want. What does that do? Well, overload protection says see overload protection. All right. So obviously there's something for overload protection because it says see overload protection. So I'm going to look for overload protection. And under overload protection, I'm going to go down, and what am I trying to find? I'm trying to find for motors. Okay. So I get to motors, and it says see motors. Okay. This is an example why I hope you learned and watched my videos on motors, because then you'll learn that motors is one of those things where you think about table 430.248, 249, 250 to get to FLC. You start thinking about this single conductors to a motor is 430.22, multiples 430.24. You start thinking about short circuit ground fault protection at 430.52. You start thinking about it for feeders for short circuit ground fault protection at 430.62, which will ultimately send you to 52. You start thinking about overload at 430.32. You got the option to do one. If it doesn't hold, you go to the next. Hopefully you get all that. And if you've watched any of my videos, you probably do by now. But it's always good to do it again. And as my son would say, is all of that stuff that I rattle off necessary? And I would have to say yes. For the electrician, it is. Do you have to remember it like that? Yeah, probably not. All right, overload protection. You'll see where you have a reference to it, and it sends you to part 4 of 430. So I'm going to go to part 4 of 430. And see if that gets me where I need to be. Might not. Might be too far. Actually, was it 4.4 or 4.3? Crap if I know. I can't remember now. I didn't look. Did I say part 4? No, that's for ground fault protection. Part 3. Oh, let me go back. Over a second. I want to double check. Oh, there it is. Excuse me. Under motors, it has overload protection 430 part 3. Okay. So anyway, sorry about that. All right, so part 3 under motors, because again, motors is what we're talking about here, continuous duty motor. It sends us to part 3, and you notice that you get to 430.32. It says continuous duty motor. Ah, okay, so we know that's in the question. Hey, Germ Bassin, welcome to the stream. We have many, many more that you can watch that we've done over the past year or more. So check them out. If you're really studying for an exam, we've been doing this for quite a while, so go check them out. There's a lot of stuff for you to watch on our YouTube channel. I think the hours itself, you could watch a new video on our channel or listen to a podcast for an entire year and you wouldn't listen to the same one twice. That means I am extremely long-winded and talk a lot. All right, so no, we know that's more than 1 horsepower. That's what's in the question. Okay. Oh, 68, Chris. So close. So close. Go watch as many videos of mine as you can, Chris. You're so close that my videos will help you. And I have put them together in playlists, calculations, or things like that. Now, if you just need to get better at maneuvering through your code book, then these sessions are great. Now, go watch the ones that I did like this previously, and there's a bunch of live ones that I've done. You can always pause it when I present a question, pause the video, look it up and answer it, and then start play again. That's what I tell people when you're thinking about a question or you're thinking about something that's online, exam questions. Get your money's worth. Stop and dissect the question, okay? Don't be too quick to kind of just boom, 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 boom. Now, I don't do fire alarms, sorry. Sounds like you're in North Carolina or something like that. Yeah, I don't deal any firearm. I have expertise in fire alarm, NFPA 72, but I don't do fire alarm except for 760 in the NEC, which, again, talks about fire alarm applications. But other than that, I really don't. I'm an NEC guy. I really stick to the National Electrical Code. All right, so 430.32, more than 1 horsepower. Each motor used in a continuous duty application and rated more than 1 horsepower shall be protected against overload by one of the means in 430.32A1 through A4. All right, so in this case, separate overload device. Okay, so this is running an overload protection device size, so we're going to always assume it's separate unless it states otherwise. And in this case, it says, and again, for those, I know people like me to go to the thing, so I'll go to the computer here. So if you got your code book, and again, this is 2020 for those that are following along, and this one doesn't change, doesn't matter. Also, here's a tip for those that are preparing for an exam. Let this chart right here be your guide. And if you can write in your code book, it doesn't hurt to write beside, like, for example, motor feeders, branch circuits, like right here, you could write to 430.52. You could write down, but you can get all that from up here, see? All of that information is up here as well. Okay. But again, it's really utilize this figure, because this really can help you if you get in a pinch. If you have a question, it's asking you something specific in this list, like it's asking you about motor overload protection right here. I don't know why it's not letting me highlight it. Oh, I guess because it's not a PDF. Sorry. So then see that was part 3. If it's asking you a question about the circuit, the branch circuit, short circuit ground fault protection, you see that that's in part 4, or in, so again, utilize this to your advantage. If there's a question about the disconnect for a motor, you see, you've got that. So don't be afraid to utilize this figure. And again, up here, it does give you code references to kind of get you in the right direction. Most of all this can be also found in the index under motors. It's going to break down a lot of these anyway. If you want to be more specific, you can do that as well. All right, so I tell people to, if it's dealing with motors, just remember that, overloads 430.32, individual circuit sizing, branch circuit conductors to a single motor is 430.22, multiple motors 430.24, things like that. You'll get used to it. You don't have to commit it all to memory, but you'll get used to it. And that's what's great about our Fast Tracks program, because you do it so much that this stuff starts coming to you. Okay. All right. So motors with a starting surge factor of 1.15 or greater, and that was in our question. It says that it was at least 1.15. It wasn't less than that. Okay. So we have 125%. So that's the answer. Now, real quick, while I'm explaining this to people, I also like to explain this rule a little bit. Okay. To think about this. So when you see the 125, you don't have to have both be present in your exam question, folks. You don't have to have it be greater. If it's greater than 1.15, then it's in the 25. Or the rise is 40 degrees C or less, then it was going to invoke the 125. It doesn't have to have both. Either or. It could have both, but either or. But I think a lot of people get confused with that and expect to see, let's say there is a 1.13 service factor, that they think that if the heat temp rise is not 40 C or less, then the 125 doesn't apply. Then that's not true. If either one of these are in the equation, then the 125% applies. See what I'm saying? If neither one of them are in the equation, then the other motors, the 115% applies. Also, something real quick to remember, 430.32A1 is under a normal condition. So you saw that question when it says that it's either not permitted or it doesn't need it. If the motor can start on the overload without it faulting or tripping out or blowing overloads, then you have to go with 430.32A1. However, if they will not, okay, if it will not, then you're allowed to go to C. And that is, let me go down here. Oops, sorry about that. That is right here. Oops, right there. Oh, I know why I couldn't do it on the other screen, because I didn't have it up on the screen. So here, so if it can hold, see that where it says where the sensing element or the setting and size of the overcurrent selected in accordance with 430.32A1 and 430.32B1 is not sufficient to start to carry the load, then you can use these percentages. And again, the 115 service factor and the 40 degrees C or less in order to kick you into the 140%, still the same. They don't both have to be present for you to get into that 140%. Okay. If either one of them are in there, then you use the 140%. Okay. Now you only get to 430.32C if 430.32A1 can't apply. And trust me, they're going to have to tell you that in the exam question. Otherwise, there's no way to get to C because you're assuming that A is perfectly fine. So they're going to have to tell you that. So always look for that in the question. If they make some statement like that, then they're going to continue on with some statement about, oh, it can't hold or it's not permitted to be increased. Then you know where you need to be. Okay. If it says it will not hold it, then you can jump to 430.32C. Okay. Make sense? Good question. A lot of stuff to think about in that question. Then at the end of the day, I don't know that we've even answered it yet. So probably should do that. So let's answer it. And there's 430.32A1. Hopefully you all got that. Incidentally, these are questions that are in the Fast Tracks program. If anybody was asking, that's where these all come from. Okay. Good question. Let's go on to another one. All right. Give this one a shot, guys. It says where a 15 amp rated general use AC snap switch. Okay, it could be a toggle switch, you know, just a normal snap switch, is to serve as a disconnecting means for a stationary AC electric motor rated 2 horsepower or less and 300 volts or less. The NEC requires the maximum full load current rating of the motor to be not more than 10 amps, 15 amps, 12 amps, or 7.5 amps. Don't guess. Look it up. Look it up in the code. I'm going to look it up too. I'm going to look it up with you. So if I was dissecting this, one of the things that I know we're talking about is a disconnection means. Okay. And it's asking me about the use of a general use AC snap switch for a disconnection means for a stationary AC electric motor. Okay. So it sounds to me like what? Disconnect. Now, if you want to use the figure, let's try this. See if it works for us. Let's give it. I know 2 directions I could go with this, but let's go and go. You got your codes book with you. So let's go back to the figure. Remember I said that figure? So if I was using that figure, and I won't bring it up on the screen, y'all remember I was talking about the figure under 430.2 or 430. What is that figure? 430.1, the figure. If you go and look underneath for the disconnecting means, motor disconnecting means, it looks like it's part 9. And that means it goes from 430.101 through 430.113. That's a small window. So let's see if that has anything to do with it. Okay, so I'm going to go to 430.101. Of course, we could go to the index as well, but I would tend to try to keep you, the thing about an index The thing about indexes is that they're very beneficial if you utilize them correctly. The problem is that if you spend all day on an exam and you feel you have to go back to the index so often, then the chances are you're going to have a little bit of a struggle because you just don't have enough time in an exam to do that, right? To be able to go back and look everything up. Now, the good news is for those that got our P-tabs, you now have the ability to go to A, B, C, D, E, go to the index. So you'll be a little quicker, certainly a little quicker. But again, I don't want you to get you so locked into going to the index. But again, the index can be very powerful, especially if you don't know where to start. And so that's why I encourage you all to watch my video on how to find the root of a question, because that's what you need to look up. So in this case, it's a motor, and we're talking about the disconnecting means. So I probably could go to the back of the index and go to motor. I won't bring it up on the screen. I'll let y'all do that, but I'm just going to look and see. And for those that are already there, some have given some references. And I'm going to go back into motors, and I'm going to look under disconnecting means. Okay. I've got some references here. Do you remember what I always say with the references? I always say make sure you go and you write these down. Okay? You just write these down so that at least you know where to go and you don't have to keep coming back in the back of the book so many times. Okay? Try to do it one time, get it as close as you can, and you'll be good to go. Now, I will tell you, an observation that I would make right away is that I don't know that it's giving you directly the answer that I would do it. You would think, oh, it's going to have something directly in there. Okay, so I would probably go and look, but typically, yeah, I'm gonna. Okay, let me hold that off real quick so we can see where some of you go. All right. So if I were to go over to motors and I were to do it like we did, it should put me in the right place. And I gave you those references first on. I don't want to give it away now. Let's let you work this a second. But you could also go back to motors and find something. Again, we're talking about the disconnecting means, and it'll send you to a certain part to come to. All right. Well, let's look and see what we've got. So it depends on your state, E. Again, that's up to y'all to check that. I don't verify with every state. Texas lets you use tabs. Many states let you use tabs. You have to check with your testing. If your exam is done through PSI, then you can go to psiexams.org, maybe what it is. I'm not sure. And you can download the bulletin for your state, and they'll tell you whether or not you can tab your code book or not. Again, so it's very state specific, right? State here, state there. All right, so Steve said it was 430.83c. So Steve, I'm going to look at your reference, even though I don't believe that that's it, but we're going to go look. And the reason that I don't believe that is because that's under motor controllers, but it may provide the same answer. So we need to look. There's multiple ways. Okay, so again, now what I like to tell people is we want to stay where it's more relevant to the question, which is you being used as a disconnection means, but that's okay. We're not asking about the controller. Now, 430.247, no, you don't want to go up there. All right, so let's see. So if I look at Steve's and I look at C, it says a general use snap switch having ampere rating not less than twice the full load current rating of the motor. Okay. So again, I don't know that we even have any rating of the motor. We just have a switch. Okay. And then it says on AC circuits, and this is an AC, it says the general use snap switch suitable only for use on AC where the motor's full load current rating is not more than 15% of the ampere rating of the switch. Interesting. Okay, so I think we're going to get that answer somewhere else, but let's do it. 15 times 80% is 12. Okay. Now let me go a little further. So let's do what I did earlier. I see some answers coming in. So remember what I did earlier? I went to the front of the book. I went to the little figure that is under 430, that little figure. And remember when I went down and said, okay, I'm going to go to disconnecting means. And it says it started at 430, 101, right? So that's part 9. Okay, so that's part 9, and it's disconnects. And you got 102, locations. You've got operations. So what I tell people at that point is use what's called bold scanning, and you scan. Okay? Now, 430, 109, which you'll learn is the type of disconnects. Okay? And you go down, and you'll see that it's talking about, in this case, it said stationary. No, sorry about that. It says stationary AC motor, 2 horsepower or less, and 30 volts or less. So those to me are triggers. So when I get down here to stationary motor, 2 horsepower or less, that's what it's asking. Remember, we're talking about the type of disconnect. What type of disconnect? Snap switch. Okay. And you get down to C, so 430.109C, you'll notice that it says, same as it did where the reference that Steve gave, although that was for controller and this is for the disconnect. I know it gets you the same answer, but I want to make sure that we know that if it was a controller question, you can get it. If it's a disconnect question, you know where to get it. So if I was grading it on accuracy on where you were getting your answer, then your answer, I would look also for the code reference. And sometimes I do that as well in my Fast Tracks program. You might have an answer, but I also am watching those code references as well to make sure it's not just willy-nilly. I'd like you to look at a question and determine that, this is a disconnection means question, not a motor controller question. If it had a said motor controller in it, then I would be in motor controller, even though it might get you to the same answer. You with me? Okay. All right. So in this case, do 12. And there you go, 430, 109, C2. There you go, 15 amperes times 80%, it's 12. Very good. Yeah, 430 is pretty long. But, I find that 430 is broken up. They did a pretty good job at 430 based on the parts. And I'm telling you, if you relax during an exam and you get a motor question, and you go to that figure, 430, which people don't do. If you go to 430.1 and you look at that figure, and then you look at the question and ask yourself, what is this question asking me? Then you dissect it with the figure, and then it puts you at least in the pages. So for us, rather than go to the index, I could have gone straight to section 9, because that's where disconnection means was, and I can use a term we use it all the time here, called bold scanning. And that is when you take information in the question and you start looking at the answers by scanning all the bold text and then looking over the subject matter in that text to see if it matches what's in the question. And so that's how we got to this one here when it was 430.109C is, again, stationary motor, 2 horsepower or less, that's in the question. And then, of course, the respective answers inside the body was 2 horsepower or less and 30 volts or less. That's in the question. So that's what drew me here. Okay, so that's just a technique called bold scanning. Again, the index isn't always going to be the holy grail, but you can also get to use those figures. And at least with 430, as 12 Mandingo says, it's a long article, but that figure breaks it down really well. Imagine how neat the code might be if every article had a figure similar to give you like a shortcut to the areas. Boy, that would be neat, wouldn't it? Okay. No, I'm not submitting that public input. I can promise you that. All right. Next question. All right. Everybody did good, good, good. At least one 125 volt, single phase, 15 or 20 amp rated receptacle outlet shall be installed within 18 inches of the top of a show window of a retail department store for each blank of show window lighting area. So what do you think? So it's a receptacle requirement. It's asking for a receptacle. Oh, I should show y'all while y'all are looking. You see the difference in the tabs where these color ones are they're see-through. They're translucent. And then of course you've got my tabs, the white on black, the black on white, they stand out. So that's what they look like. In case you didn't see it. It's just much easier. Am I really stumping my P-tabs tonight? Whoop, 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 whoop. Limited supply. All right, where are we at? Okay, so this looks very much like a receptacle requirement. So you got to ask yourself where in the code deals with those type of requirements for receptacles. So somebody throw it out at me. Kind of help me out. Now, feel free to use your index because again, it doesn't do me any good to give you the answer. Okay? We need you to be able to understand it, look it up, and find out where it might be in here to help you be able to answer the question. And I'm going to say no, Elwood. Try again. Because I'm not asking anything about a VA. I'm not asking anything about a number. And just for craps and giggles, I'm going to go look at your reference because that should not have anything to do with answering this question. So I'm going to go look. Nope. 220.14g plays no role in this question. Remember here, so what's the triggers here? It's asking about a receptacle outlet. Hey. Well done, Alfie. Alfrey. Well done, Brian. Brian's in the house. Hey, Brian. Welcome. Okay. Whoops. Hold on. It's going to cut me off, folks. All right. Hold on. Back. All right. Okay. So the question is absolutely D, and it is 210.62. Very good, Monty, as well. Alfie was out the gate, though. Alfrey. Sorry, I'm going to say Alfie. Alfrey was out the gate. Definitely. And there's your reference, 210.62. And this one, guys, just remember when you're dissecting a question, this is very much asking about a receptacle outlet. And when you're thinking about that, remember, those are in 210.52, 210.60, 210.62, 210.63, 210.65, which is now the change for the meeting room receptacles. All those are dealing with receptacle locations. Not asking you for a VA, not asking you for a calculation. This is literally asking you, hey man, I need you to put a receptacle up there. It's a receptacle requirement. If it had been a load calculation, then you would have been in 220. But it wasn't really asking anything to do with a load calc. Okay, so didn't have any real reference to that. But y'all are getting it. All right, let's see here. Let me go to another one here. All right, so this one might throw some people. It says at an outdoor, let me make sure I'm on the screen. There we go. At an outdoor motor fuel dispensing facility. Okay, so we already know one thing. It's a motor fuel dispensing facility. It should send up red flags, right? Like bing, 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 bing. You know what I mean? It says the area up to 18 inches above grade and within 20 feet horizontally from the edge of an LPG dispenser enclosure shall be classified as blank hazardous location. Okay, so class 1, class 2, class 1, class 1, class 2. I should, you really need to go and think about this. So this is dealing specifically. Now, before you spend your time going into 500, 501, 502, 503, remember we're dealing up with a motor fuel dispensing facility. So that's the core root of the question. Also remembering that the actual references to 18 inches and 20 feet is what you're going to be looking for in the code language. That's called bold scanning. They're going to help you answer the question. Okay? Unless you just already know the question, this is going to help you. So, motor fuel dispensing facility. Now, if you have a tab, you probably have a tab for this. Okay? If not, 2 ways to get there. One, if you understand that motor fuel dispensing facility is an actual article in the code, you could go to the front and look at the table of contents. Okay? And that might help you. If you're looking down and say, okay, where is it? I need to get in there. And you look down and you say, okay, that's going to be under what? Well, that's going to be under special occupancies. So you look down and you say, well, motor fuel dispensing facility, that is under 514. And then it takes you right to page 414. You can start your journey. Or you could go to the back of the book and you could look under motor fuel dispensing. See what you find back there. Now, people ask me, why do I like to, at least when we're, why do I like to use the index when we study? Because the more that I can get you in there, it helps reduce the amount of time that you're locked in there when you're doing your exam. You get there quickly because you do it so often that you learn little nuances of the index to help manage your time better during an exam, right? So motor fuel, liquefied gas dispense. Let's see here. So I'm going to go under motor. See if there's anything under motor fuel dispense. There we go. Motor fuel dispensing says see Article 514. Now in here, I'm looking and saying classification is what I'm looking for. So see here it says classification of locations. 514.3. That's enough to get me where I need to be, 514.3. So I'm going to go to 514.3. And again, you could have probably just gone, since it's not very big, you could have gone to the beginning and you could have bold scanned it. Okay? So at any rate, 514.3. And we're here. And since we're dealing with what? We're dealing with what? Outdoor? Right? Let's see here. We got some... I got some answers. I think Brian says C, Class 1, Division 2. I think that's what you're saying. All right, so outdoor dispensing. We're looking for, there's 18 and 20. So if you were to go look real quickly, you'll see you have dispensing device. You have dispenser. Okay. And I'm just looking down. I'm going to make sure I got some, nothing else. Yeah, that's what I'm looking for is this. Who was it that asked that question? Elwood. So Elwood, that's what I was sorry about that. I'm looking for something for Elwood. Elwood, if you go down and you look at table 314.3b2, you'll see the designations for the liquefied petroleum gas, the LPG, the LNG, hey, what's up, O? Thanks for coming. Compressed natural gas, CNG. You see it there? Okay. So do you see that down there? So I assume he hears me. I'm assuming you hear me. Okay, so anyway, so 514.3b2, and you actually have and the reason, Elwood, that gives you the descriptions as well for those unique types. Okay, so these are unique types. It's the CNG, the LNG, the LP gas, and all those are classified right here. So you see all the aspects. Okay. Now, if you read the example over in the Class 1 Division 2, the bottom one, it kind of mirrors exactly what they're asking here. So, but I wanted to make sure, because you had the question mark about what let me move my thing back over here. It's out of my way here. Sorry, folks. You asked what the LPG dispenser was. Again, it's just liquefied petroleum gas, but very good. I think everybody answered that one. So now there was a bit varying with the different responses, but you all were in the right location. So it's all good with that one. So that one didn't trick anybody. Either that or y'all are just really getting good, and my work is done. Right? All right, so let's look at this one. All 125 volt, 15 or 20 amp rated receptacles located within not more than blank of the inside wall of the storable swimming pool or hot tub shall be protected by a ground fault circuit interrupter. 15, 20, 10, 25. What do you think? Don't guess. Go look it up. Now, the first thing you'll notice that it's a storable swimming pool or hot tub. So it's a storable. Now, the way they wrote this, it makes you think it's storable swimming pool or a standard hot tub. But I believe what they're saying is that it's a storable swimming pool or hot tub, both of which are storable type. Now, that's important because that puts us in a certain location in what article? Mandingo's got us a reference. Oops. Okay. Now I'm going to go with my code book as well. Now, if you were doing this and using your index, if you didn't know, well, one of the things that you should do is get familiar with the different parts. Now, if you remember over on our YouTube, the subscription thing, we have a series of videos on Article 680. It's about 8 of them, I believe, that you can watch that really goes over everything that have to do with Article 680. We'll cover just about everything that you'd run into. All right. Now, if you do notice that you'll go to, it'll be in part 3 of 680. Again, storables, you can get there multiple ways. You can go to the back and storable. Now, if I wanted to do that, I'm not going to go to storable. I would go to swimming pools because I don't know that there's any reference to storable, but let me look real quick. And that's why we like to use the, get used to the index. Yep. So again, you're going to waste your time in the future. It's not going to make a difference. But you go to swimming pools and you go to, look down, I see storables. It tells me it starts at part 3. And so I'm going to go to part 3. Part 3, and then I'm going to go down, and what are we asking? What are we talking about? We're talking about receptacles within a specific distance. Now, this is an example. It's a little trick for guys out there who are preparing for an exam. Now, when you're in the fast tracks, I want you to learn the code. When you're doing an exam, it does pay benefits to use the answers and the question to help find your answer. So in this case right here, the question is asking about GFCI protection. So I'm looking at GFCI protection. So that's what I'm kind of triggering on. So when I'm looking at, just real quickly, when I'm looking at the bolds, and the bolds are the actual code reference, and if you're using this during an exam, is I'm looking for the bold references that are going to specifically address dealing with receptacles. Okay? And want to see what kind of reference would I have. Now, interesting. If you look, again, there's a couple ways to get here. If you were to look at the, in the 2020, again, by the way, I should say that's what I'm in. If you look at 680.35 and you go and you look at G, just for craps and giggles, if you were looking for it, that talks about the 20 feet from the inside wall, and then it tells you got to meet the rules of 680.32. And 32 is dealing with receptacles, right? So it kicks you back that way, okay? So it's one way to do it. It's not the only way to do it. It's one way to do it. But if you're looking for those bolds, and again, part 3 is short. What is that, a page and a quarter? So if I'm doing it, if you'll notice at 680.32 in Monty, 22 is going to be in permanently installed pools. This is a storable swimming pool. So we want to be in part 3. So if I'm looking at 680.32, you'll see it says all 125 volts, 15 and 20 amp receptacles located within 20 feet of the inside wall of the storable pool, storable spa, or storable hot tub shall be protected by ground fault circuit interrupter. So the answer is 20 feet. Now, good news is, Monty, for an exam, the receptacle distances and GFCI protection requirements, good news is they pretty harmonize. They harmonize pretty well, okay, with each other. So they work together pretty fine, so you're going to get the same answers. But I just want you to identify, one of the important things is that the storable was one of the triggers. We knew it was swimming pools, but the storable is what put us in part 3 of 680. If it was a permanently installed pool, very much you would be back in the part 2 for storable, for permanently installed. But we're dealing with storables. Okay. And there's a 680.32, as we said. Very good. Okay. Now I'm going to make you have to work a little bit now. Okay. All right. Determine the conductor's ampacity, giving the following related information. Okay. Now, don't assume that the code's right here. Don't assume that this question is right. I tell people in our programs all the time, don't assume, because I did not write all these questions, and I'm certainly not perfect, but I did not write all these questions. So you never want to take, and I tell people that are in the Fast Tracks program all the time, feel free to, if you think you got something right and I mark it wrong, come back. I want you to interact with me. That's what I'm here for. Hopefully everybody that's in the Fast Track program, after they submit a competency review, hopefully you go back and you read my comments, because, you know, the comments allow you to really see my explanation of why you got something wrong, and you get to learn from it. It's not always about getting it right. Sometimes you can learn more by getting something wrong. Okay. So again, success is accumulation of many failures. And again, I have a philosophy that I tell people all the time. Philosophy of education for electrical exam preparation is repetition. Doing it over and over and over again. And it's okay to get something wrong. Okay? It's all right. Don't give up. Never give up. We're not in this world to give up. I'm not even giving up after November 3rd if I don't get my way. Come on, Come on. All right. Anyway. All right. So we have an ambient temperature of 44 degrees C. Hopefully you guys are working this one out. We have a 250 kcml THWN. I'm working it with you, brothers and sisters. I know I got some of y'all out there too. 12 Mandingos. That's a confidence. He says, I'm going with B. There you go. And then we got 4 conductors. Okay. And it says that they're all current carrying. Okay. And the length of the raceway is 30 feet. It didn't ask me about voltage drops. So I don't care. All right. So the most important parts of this question, folks, is, believe it or not, that THWN, because there's no -2 on it. Remember that. So that means that it's only good in the 75-degree column. But again, I can use a 90 for adjustment and corrections as long as I don't exceed the values of the 75-degree. But that THWN is only rated for 75 degrees C. So guess what? I have to do my adjustment and corrections from 75. And I'm pretty sure that's where Mandingos is going with this. Okay, so let's work this out. How we do this? Get my paper. All right, the first thing we need to do is we need to remember that anything other than 30 degrees C or 86 degrees Fahrenheit, that's what's in table 31016 of the National Electrical Code. And for those who are in the 2017 code, that's 31015 B16, which is no longer that anymore. In the 2020, it's 31016. So what we need to I like how I say that. We need to also now understand that since the temperature is not 30 degrees C, 86 degrees Fahrenheit, we have to go where? We have to go to 310.15 B. All right, so let's do that in your code books. Follow along with me. We're going to do the first one first. We're going to get the value that we need to calculate with the 44 degrees C, because that's not 30 degrees C. Always remember that. Okay, so let me do it. And these tabs suck. I encourage you to get my tabs before I don't have them anymore, because if you've got these clear tabs on your code book, you are going to be in a world of hurt. All right. So under 310.15 B1, we're going to, now here's the other thing. Remember, we have to use the insulation rating. Since it's only THWN, we can only use the 75. So we got to come down the 75 column. Should I show you this on the screen? Y'all want to see this? I mean, I'll do it. I want you to learn. And I had a guy send me a really nasty email or a post a couple weeks ago, and he said that I'm too redundant, and he doesn't understand me, and he doesn't understand why I do it the way I do it. So I didn't let him get to me. But I mean, again, they don't understand my method of teaching, but that's why I have literally thousands of people who have been successful. Anyway, so here we go under this column. We have to be under the 75. Why? Because it's THWN. Doesn't have a 90-degree rated insulation. So we got to come down. And what do we say? 44 degrees. Is that what it was? It's 44 degrees Celsius. So we got to come down here, Celsius. So we're here. So the multiplier is going to be 0.82. So let's write that down, 0.82. All right. Makes sense. All right, let's go back to the question, and we'll do the next one. I know I'm slow, folks. I'm from Virginia. I live in Texas. Everything's slowed down in Texas. All right, so the next thing we want to look at is it says 4 current carrying conductors. Well, remember 31016 says it only applies to 3 for any over 3. And we're over 3. We got 4 current carrying conductors. So since the table doesn't apply as given, we now have to do something, and that is 31015 C1, which used to be 31015 B3A and 3B, but that's changed for the 2020. Okay? Just remember, you got to do an adjustment or you have to do a correction. Okay? All right, so let's go to the code. Remember, we already got our first one. That is 0.82. That's dealing with the ambient temperature issue. Now let's go back to the NEC. And for those that say I'm moving too slow, sorry. All right, so now since we got 4 to 6, here's our C, 31015 C1. And this is a adjustment factor. The other one was a correction for the temperature. Now we're doing adjustment for the number of current conductors. 4 to 6, it is 80%. Of course, we always do what? We take a point here, we move 2 decimal spaces to the left, and 80% is equivalent to 0.80. As a multiplier, we want to make sure we break it into decimal form. So 0.80 is our multiplier for that. You with me? Okay. All right. Now we can go back and do some work. Oh, while we're here, let's go on and get the ampacity of, I believe it was what? A 250 kc mil THWN copper. I believe that's what it was. So while we're here, let's go on and let's get, now here's the table. You see 31016 now. All right. So THWN right here. You notice that THWN is not under this 90. It's right here. Okay. So 250 is good for 255 amps. So write that down. You need all these things, man. All right. Now we can go back to the question. Because that 30 feet, that don't mean squat to me and you. All right. Unless we're doing voltage drop. And again, 30 feet ain't going to affect voltage drop for this one anyway. All right. So remember, it's 255. Multiply that times 0.82 times 0.80. And that is 167.28. The best possible solution of answer here is 167. And there's a 6, there's the 28, but again, you can't, of the questions that are being asked, it's 167. It wasn't, you didn't have a 168 and it was a 0.2, so you don't round up, so again, you drop off anything that's 0.2, anything that's, again, at the end of the day, anything under 0.5, you drop off, okay? All right, so 167 is your ampacity value. So, let's see here. I think, who was it? Was it Mandingo was right out of the gate, right? So hold on, Mandingo. Here you go. I see you, Ronald. I see you, Monty. There you go. Make sure before you do an exam that you know how to do those. Also, make sure that you really, really understand why you couldn't use the value under the 90 degree. Because this insulation isn't good for 90. It only has 1 H. It's good for 75. Okay? So make sure you get that. Okay? This same question gets changed if this happens to be a THWN-2. Because if that's the case, then I can do my adjustment and correction from the 90. Okay? And subtle things, man. Subtle things to remember during, for an exam. I want you to be successful. Okay, I want you to really understand that because you get all types of questions like this on an exam. All right, let's go to another one. Y'all are doing great. I know every one of you are going to be successful. All right, next question. Determine. Oh, yeah, this is definitely something that I see on exams. Okay, I can already tell. Minimum number of 15 ampere, 120 volt general lighting branch circuits required for a 12,000 square foot multifamily dwelling where each unit has cooking facilities provided. Okay. So a lot of words there. It gives you a lot of information there. But again, all I'm asking you for is, hold on, what is he saying here? Wouldn't you grab it from the 90 because you're adjusting, correcting? No, because you can only get in the 90 column, like Bill says. You can only get into the 90 column if the insulation on that conductor is truly rated for 90. And THWN is not rated for 90. Here's a little quick lesson. T means thermoplastic. H means high heat. It's equal to 75. If you see TW insulation, for example, there's no H's. It's good for 60. If you see THHN, it's 2 H's, means it's good for 90 degree insulation. Okay? So kind of the way to remember, the only one that can throw you a curveball is XHHW. XHHW is only good for 75 when a wet condition, but 90 dry. Whereas XHHW-2 is good for 90-degree wet or dry when it comes to adjustment and correction. So the only one that I tell you that throws you kind of a curveball is the X. And that's cross-linked polyethylene. Because just because it's got two H's in XHHW doesn't mean and it has a W, doesn't mean it's good for 90 in the wet. Okay? It has to have the -2 on the end of it to be good for 90 in the wet. It's good for 90 in the dry locations. Okay? And you'll learn that by going to 3.10.16 and look at the header, and you'll notice that XHHW is in both columns, the 75 and the 90. Why? Because you got to go all the way back to 3.10 and read the nomenclature, and it'll tell you that XHHW is only good for 75 in a wet, but you add that -2 on the end of it, it's good for 90. So guys, the tip of the day is read your question, because they might throw that curveball in there and use an insulation rating that is less. And you start seeing adjustment and corrections, and your mind goes, I'm going right to the 90 because the code says I can use it for adjustment and corrections. That's true. But only when the insulation is rated for it. Kevin, they are. But I like to tell people it's not a set thing. I don't do it every Wednesday. I usually do it on Wednesdays. But again, I had some issues yesterday, computer, and I was tired because I'm back at work now, my normal driving to my office, and I couldn't get the computer working, and I was tired, so I just said, forget it. So I decided, you know what, I'd do it tonight and kind of give back a little bit tonight if I could. So yeah, so normally it is on Wednesdays, but to be honest with you, computer was acting up. And it almost acted up tonight. That's why I was 2 minutes late tonight. It was acting funky. I don't know what the deal is. Anyway, enough of that. But yeah, you're right, Kevin. Usually I do it on Wednesday nights, and that's where we'll go back to it if I can do it to be more consistent. All right, so anybody answered this question yet? Because I gave it a long time of rattling on, and nobody's answered this question. So it's a lot of words here. Tries to tell you that's a multifamily dwelling. Doesn't tell you how many. It tells you that there's cooking. Remember, this question, people start, thinking a lot. This is a good question to make sure people look at it and go, wait a minute. All this is asking is for the minimum number of 15 amp circuits. Already, Mendingo's is already headed up to 220.84 to do a load calc. It's just asking you for the general lighting, receptacle circuits, branch circuits. It's not asking you for a load calculation, okay? It's not even telling you how many multifamily dwellings there are. It doesn't really care. It's telling you that there's 12,000 square feet. It's not even requiring me to do this times 3 VA. It's nothing. It's already telling me. It's already telling me that it is 3 VA. Now, Monty, is 7 one of the options on the screen? So you have to, let me do my math here real quick. I run my mouth. And I absolutely 100% know where you went, Monty. I get it. I'm with you. Okay? I'm with you. So it says 1,200 square foot multifamily dwelling where each unit has a cooking facility provided. This is an example of, and I see where some people are going with this. This is an example of poorly worded question. Okay? Poorly worded question. Because in order to be the multifamily dwelling, you have a single family, you have two that would be a two-family dwelling, and then a multifamily dwelling is 3 or more. Okay? And it doesn't say how many. So again, I'm stuck with, okay, it's required for a 12,000 square foot multifamily dwelling where each unit has a cooking facility provided. Pretty poor question, okay? The whole concept of the question is pretty poor, all right? So, and I never said all of them are great, and I'm chastising, but I'm not necessarily chastising. I can't remember. Hold on here. Yeah. Okay. Just wanted to make sure I'm not. I'm going to make sure I'm not going to give you, yeah. Okay. Yep. So they gave you some values here. And they gave you the entire amount. But what they did not give you in here is a certain VA per square foot. As I said earlier, they didn't give it to you. They flat out gave you and told you the square footage. You didn't have to do dimensions, right? You didn't have to do anything other than that. All you had to do was know that it's one is a multifamily. And so 220.83. Now I chastised Mandingos for this, didn't I? I think I said, "What are you doing, boy? What you doing going up there?" Okay. So hold on here. Yeah. Okay. There we go. So again, you were right in going to 220.84. I apologize. I mean to chastise you in that. Divided by, yeah. Okay. But you're right. You did need to go up there because you were dealing with 3 or more. I don't know why I did that. I'm not sure I chastised you for that. I apologize. Hold on. I got a button for that. Because I'm a worry, then I'm a worried that I was misleading you, Mandingos, from getting the answer because I wanted you to think 3 VA per square foot times the 12,000 square foot and just immediately do the answer based on the VA from 15 times 120 volt because the 3 VA per square foot for general lighting is consistent through all of them. But you would have gotten there 220.84. So again, my apologize. Mandingo, send me your email, your physical address, and I'll send you a goodie in the mail. Actually, I'll send you an, because I chastised you. I sent you in the wrong direction. I had a mission on my mind, but I didn't want to do it. I'll see if I've got one of my books. If I got one of my books, the recent books, I'll sign it and send it to you. Just send me your email address. Yeah, no, the VA is the same. That didn't change. And I was kind of skipping the math and, not have to run there and look. I wanted you to just do based on what's here. But you would have gotten there if you had gone to 220.84 anyway, but you would have gone down to the C, and that's how you would have gotten there. But anyway, we got to do it. So there it is. So there's the 3 that I wanted you to do without having to go to it. Because if you see the reference in J, that's where I really needed it to where I wanted to be. But again, you see that we got there, the 1800 VA equals 20 circuits. So there's a couple ways to do it. I wouldn't necessarily gotten there by 220.84, but you could have, and you would have gotten there if you had gone to the calculation. So that's why I feel bad that I told you where you're going. It's not really where you needed to be for the answer to that one because it is a dwelling unit. And if you'll notice under J, It says multifamily dwellings, all of them still use the 3VA. So that's really where I was trying to get you to go. So, but I feel bad that I jumped on you for that, because you could have gotten the answer by going there. At least you would have got the 3VA per square foot, but then you would have to remember to do all the other crap too. So, so I feel bad for you. All right, let's do another question. I feel good for all you out there that got that one though, because that was not so easy. Except for the fact you remember that cooking and all that crap didn't make a hill of beans. And that's why I was afraid, Mandingos, that you were going to go down that road by going to 220.84, because the answer still could be gotten there, but it was far better to be at 220.14J. And this says 220.12J, but this is an error. This should say 14J. Okay. So yeah, see, so errors are in there, but that should be 14J. All right. Next. The scenic route. Yes, you did, but you would have come up with the right answer, so it's all good. All right. Answer this question. In a farm building where livestock, now you won't get this question asked if you live in Nebraska. If in a farm building where livestock is housed and an equipotential plane system is required because the wire mesh or other conductive elements are embedded or placed under concrete and bonded to the metal structures that could become energized, the equipotential plane is necessary to minimize blank differences within the plane. Voltage, wattage, current, or resistance. Okay. Now, first thing to remember is when we say farm buildings, so in case you get questions that are just like this on an exam, when I say farm buildings, you know what I'm talking about, right? I'm talking about agricultural buildings, right? So one thing you could do is go to the back. If you didn't know that, now you do, and you'll never let it get out of your mind again. But if you go to the back and you look at the index, because you weren't familiar with it, then you see if there's something to do with agricultural buildings in here. Not knowing that you actually do have a very good answers are coming in. You do have a code reference for agri. You have a tab. You should have a tab for it, I guess. But if you notice under agricultural buildings, it is 547. Now, under 547, you'll see that the equipotential plane bonding is a 547.10. Nobody gave a code reference yet, so we're going to assume that's the one. But I can promise you that 547 is very short. So if you're on an exam, time is of the essence, right? Time is of the essence. You can actually go on and go to 547, because if you look over in all of the references in the back of the index, you'll notice that there's only like a 0.9, 547.4, 0.10. So it means it's a very small article. So don't waste your time. Use bold scanning techniques and go to that one there. And hopefully you have a tab for that. You might not. I don't know that we do a tab for agricultural buildings. Probably not necessary. But anyway. 547. God, I can't see these tabs. Did I mention that this newest easy tabs stink? Yeah, I'm sure I did already. Probably already said it. All right, 547. We're here. And then what are we looking for? We're talking about the equipotential plane. So we have the equipotential plane, and you see there's a definition for that under dot 2. And it says an area where the wiring mesh or other conducting elements are embedded in or under concrete, bonding all metal surfaces and fixed non-metallic, non-electrical, equipment that could become energized and connected to the electrical ground systems to minimize voltage differences within the plane. So very good, Mandingo. Bill got it as well. So there we go. Definition. Hold on for a second. I got all kinds of buzzing going on. Hold on. Turn these things off. Okay. All right. Sorry about that. All right. So very good. But remember though, farm buildings, agricultural buildings. Okay. Don't be go hunting through the word farm anywhere in here. Okay. Well, you will find farm in 220 part 5 when it comes to calculations for farms, things like that. All right. Next question. This is a given. A feeder is to supply two continuous duty induction type design B 208 volt 3-phase AC motors. One is 10 horsepower, one is 7.5 horsepower. The feeder shall have an ampacity, current carrying capacity of at least. This is one you better get. This is one we say that, what is that, Eddie Murphy? Happy. Anyway, you got to know how to do this, folks. You got to know how to do this. So I'll walk you through it. And this is the kind of stuff we're going to have during my seminar on November 21st. 6 hours of just calcs, okay? Not exam prep, although, again, you're going to learn all that, but this is about calcs. We're going to talk about all the different types of calcs that we can talk about in one episode, one sitting. Okay, if you want more information on that seminar, go to our website. You can get the information on it. It's not a free one. But if you think about the educational value of 6 hours of calculation after calculation after calculation, it's got to be something, right? All right. And I'm also going to make sure that the presentation for that seminar is available after the seminar for you to download for those that attend it, okay? Which will, for you can do it at your own pace. It'll be a PDF version of it. Okay. Anyway, back to what we do. All right, so what's the first thing that we always do when it comes to a motor? I can't do nothing unless I get FLC, right? I got to have you got to give me some amps, man. So the first thing I want to do is I notice it's 3-phase AC motors. There's a 10 horsepower. And there's one 7.5. So since this is 3-phase, I'm going to go to what table? Somebody tell me in 430. Obviously, it's a motor, so we're going to go to 430. So what table would we use? 4 208 volt 3-phase. Which table? Somebody. I know y'all out there, y'all know. Now you do have a tab for these, by the way. Every one of them, every code, every tab, every person that makes tabs has a tab for these tables in the code book. All right. So 430.250. Absolutely. Good job. All right. So induction type, it says induction type. Okay. Don't even have to worry about the design B for this. It's induction type. And incidentally, most continuous duty motors are design B unless state otherwise, by the way, in case you ever wondered that. So under 208 volts, we've got the 10 horsepower one under 208 is going to be 30.8 amps. And the other one is a 7.5 horsepower. That is 24.2 amps. Okay. All right. We good to go from there? All right. Bill's already worked it out. Now, what code section do we go to next? Remember when I said you had motors and we were talking about a feeder? And we said single conductors were 430.22. But what did we say? What code reference did we say was when we're dealing with more than one motor? Somebody hit me with that code reference. Since y'all got some answers there, I'm assuming you know that code reference. So that code reference is, I guess there might be a delay, so I have to realize that too. I don't know, the stream looks pretty healthy, so shouldn't be too much of a delay. So if you had 430.22 was for a single motor, remember what I said earlier, when you have more than one? Servo motors? Be 430.24, right? No, not 430.32. That's overloads. We're not doing overloads, Bill. All right, so 430.24 is dealing with sizing the conductors that are supplying servo motors. Okay, so, and I'm going to explain something to everybody here because I think this is an important thing that people should know. Okay, this is an important thing I'm going to talk about right now. So I'm going to go to this 430.24 because this is kind of something that I always think that students should know, because this is kind of, they play on you on an exam. Not because they're trying to. Oh, first of all, anyway, we were talking about conductors, right? So here's the conductors, 430.21 through 430.29. So all motor circuit conductors are going to be within part 2. So that could have at least given you a shortcut if you didn't know to go to the back. Okay, motor feeders, 430.24. So that could be under part 2. That's a good way to let you know. Now, I tell people, if you can write in your code book, not everybody can, not every state allows it, or not every testing, but right here, a lot of times I will put up here a single motor branch circuit, 430.22. I'll write that up here above it sometimes as a little cheat to remind me. Okay, but you can only do that if you can write in your code book. Don't say, Paul said I can write in my code book. Got to check with your local state and see if it allows you to do that. Okay. Oops, I went too far. All right. So here is for servo motors. And again, we're talking conductors, so that kind of germane to the question. Now, it says 125% of the full load current rating of the highest rated motor as determined in 430.6a, which is what we just did. Be honest with you, 430.6a is what we just did. It sends us back to the back tables to get the FLC, right? That's the full load current. All right. Then it says the sum of the full load current rating of all the other motors in the group. Okay. Now the sum means just face value. Now here's what I usually have to explain to people. People ask, what does this mean in the group? Okay. I'll make it as simple as I can. When I've got one feeder and it's a black, a white, and a red, let's say, red, white, a black, red, blue. In this case, this is 208. A black, red, blue, and it's going out to the motor. And because I have that motor's being supplied by the 208, the other motor's also being supplied by that same 208. So they are connected to the same set of conductors. They're in the same group. You with me? You with me? Okay. So if I had a feeder going out and I had different motors, and you had one motor that's connected to one of the phase conductors, but then the others are connected to the other phase conductors, then they might not all be in the same group. In order to be in the same group, the motor has to use the same conductors as the other motor. That's considered the same group. Okay? All right, so, and again, during my seminar, I'm going to show pictures of motors, and I'll explain that in even more detail. But I wanted to give you an idea what it meant by the group. So in our case, both of these motors are being fed by the same feeder, so they're obviously using the same conductors, so they're obviously part of the same group. They're being fed by the same black, red, blue. Okay, so they're in the same group. That's what that means. Okay, I know a picture would be worth 1,000 words, but I will have that when I do my seminar, webinar, whatever you call it. All right. So we had 125% of the largest, which is the 30.8. So let's do 30.8 times 125%. That's 38.5 plus 24.2 is 62.7. Okay. So let's go back. And 62.7. Y'all had 68. Everybody had 68 up there a lot. Okay, well, we're going to see who all is right. I'm going to say 62.7. And I'm correct. Yay! I don't know where that 68 came from. But now that you understand that you're going to go to where? 430.24. That's what's going to give you the direction here. 125% of the largest motor, and the sum, which is the full FLC value of the other motor that's in the same group. Now, since there's only one feeder here, then they obviously both have to be in the same group. And the grouping, again, is all about the conductors that are mutual between motors. If they share connections to a feeder, the same feeders, A, B, and C, then they're in the same group, if you will. Okay? I will have graphics when I do my thing. Kevin said, what? Where are you lost, Kevin? Where are you lost? Let me help you out. Let me help you. So 430.24, we have multiple motors. It says the first one, the largest one, has to be at 125%. And then it's the sum of the other motor, which in this case was 24.2 amps. Then you just add them together. So one of them has to be taken at 125%, but the other one just at the sum. Okay? All right. I ran the numbers, man. All right. Sound like a bookie. Oh, there you go. See that? There you go on the screen. 30.8 at 120, 5%, and 24.2 at 100%, 62.7. Just add them together after that. All right, last one tonight, guys. We're going to get off. No, Kevin, you'd have got it right. Just focus, my friend. Now that you know the ways of the code. All right, you know it now. All right, so last one for the night, because I know we all got to get the things and do our family things, and I haven't seen my wife since I got home at work. So again, she's getting neglected more than anything. All right, let's read this one. For either overhead or underground primary distribution systems exceeding 1,000 volts on private property, the service disconnection means shall be blank. Wow. All right. So first thing we says exceeding 1,000. So this is over 1,000 volts, right? Okay. You probably may or may not have a tab dealing with over 1,000 volts. You may or may not. But the question here is asking about a service disconnecting means. Right? You with me? Y'all with me? Y'all feel me? So, first thing that comes into my mind is I'm thinking, okay, sounds like this is a service question. Service disconnect. Okay. Service exceeds 1,000 volts. So this is another little neat, nifty little figure at 230. And we'll see if that finds us the answer. So it looks like part 8 is dealing with services exceeding 1,000 volts. So let's see if that gets us the answer. If not, we got to hit the index. But let's just see here. 230. It's part 8. And see what we got. And see if disconnection means, if this this helps us at all. So overhead, okay. Now location. So this is talking about this, the blank. It's obviously is talking about the service disconnection means shall. And if you look at the questions, the answers, I guess, it's all about location, 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 and everything about that. So if you look at part, again, how quickly we got to that, because we knew it was a service. We knew it's dealing with it over 1,000, so it's got not what me and you usually deal with. So I went to the beginning of 230. Rather than go dribbling through the back of the index, I went to 230 because I remembered that there's a figure in 230, just like there is one in 430. And I went there and I saw the services and dealing with over 1,000. That's what we're talking about here, exceeding 1,000. So it says under 230, and again, all I did was bold scan until I found the disconnecting means, because that's what we're looking for. Hey, Kevin, I like how you think there, buddy. It said, it's called redemption, Kevin. All right, it says, location, the service disconnecting means shall be located in accordance with 230.70. Then it goes on to say, for either overhead or undergrounded primary distribution systems on private property, the service disconnect shall be permitted to be located in a location that is not readily accessible. Okay. Not readily accessible, comma, if the disconnection means can be operated by mechanical linkage, blah, 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 blah. So let's see here. Permitted to be located in a location that is not readily accessible probably fits this answer correctly. Okay. So, and 230, that 205A. I think you were absolutely right, Kevin. Now, I can't understand if you picked A originally and then you switched to C, but you got the answer. That's the key. The key is you got the code reference, so I knew you were in the ballpark. All right, y'all want to do one more? Y'all are doing so good. Let's do one more, and we'll see here. And let's see here. The first one that finds this answer correctly gives me A, B, C, or D and the code reference. I will send you one of these nifty screwdrivers. Remember, you can donate during any of the streams. If you donate, we'll send you one. But here's one right here. Whoever answered it gives me not only the code reference, but A, B, C, or D. Let me know which it is. The first one to give me the full accurate answer and the code reference. Don't split it up. Put it on one line. Give me the answer. I'll send you one of these. Says, when a buried ground ring encircles a building is used as a grounding electrode, at least 20 feet of bare copper conductor, not smaller than blank. I would expect that y'all have got this one already. So it's talking about what? Grounding electrode, talking about a ground ring. You can go to the back of the book, but you should remember we said a couple times ago, I said, you remember ground rings. In 250, you got 250.50, which talks about you having to meet one. And then you've got 250 that says it has to be a certain size. Sadly, Alfred, come on, you got to give me a size. Give me a size. You only gave me a code reference. Got to give me a size to be accurate, to get it right. There you go. Okay. All right. So 250.52. Oh, look, and even Bill didn't give me the answer, right? So Alfie broke it up, but might be the right answer here. So we know that the answer is 2 gauge, but let's look at the reference. God, these tabs suck. You can bet your butt what I'm going to do is next time we meet, I'm going to have my tabs on this code book. Okay? My tabs. All right. So 250.52 we know is dealing with the electrodes. Either that or I'm just getting old. I can't see through these things. It's terrible. Any of you else got these easy tabs that I hate to down them, but they really suck. All right. So A4 is the answer. 2 gauge in Alfred. You got it. Ding, 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 ding. So Alfred, send me an email at info, I-N-F-O, that's I-N-F-O at masterdnec.com. Send me your address, and I will send you out one of these. Heck, I'll even send you one of our lights as well. Ooh, how about that? Got our name on it and everything like that. Okay? All right. All right. That's it for tonight, guys. Hopefully y'all got something out of that. Hopefully it was educational and you got something. Again, we'll do this again next week. We'll be Wednesdays as normal. I got a little treat for you. I believe we'll do a couple little sneak peek. The email address. Oh no, 12, you didn't get it. No, this is only Alfred. He won. But it's there you go, info at masterdnec.com. Yep, just put .com on the end of that. But again, I appreciate all of you, and hopefully I help any of you out. If you're interested in our Fast Tracks program, check it out. Again, it has these questions, but again, we teach you from the very beginning all the way through the code. You just, you just got to be diligent at it. Some of the units in our Fast Track are tough. Units 8, 9, 10, 11, 12, and 13 are tough. If nothing else humbles you, when you start getting those really low scores, they will humble you. Okay, there are some tough questions. But again, tough or good. You want it to be tough. You don't want it to be easy, right? So Brian will tell you, he went through the program. So, all right, guys, that's it. Till next week. We will hit it some more. But next week I might give you a sneak peek of some calculations. Okay, give you a little bit of a sneaky peeky to what I'm going to do on November 21st. Maybe just a sneaky peek. Okay. Till next time, folks. Stay safe. God bless. Appreciate you all.